So, most of us are used to seeing the square root symbol. But there are other radical signs that exist. So there's the square root symbol with a 3 in it. That's called a cube root. Radical sign with a 4 is a 4th root. Radical sign with a 5 is a 5th root. A square root doesn't have a number outside of it, but it is understood to be 2. Why? It's a square root. So that number will actually be important when we start bringing variables into the mix. So these are different types of radicals. That's called the index. Index tells you what kind of radical you're dealing with. The radicand is whatever's inside. Now, listed below are the first 12 perfect squares, first 12 perfect cubes, first 12 perfect fourths. Fourths doesn't have a nice, neat name for it. By all means, the perfect squares you should be able to do off memory. Perfect cubes to a certain point. Perfect fourths, I don't expect you to know a good chunk of those by memory. About half of those I use the calculator to get. I don't know 12 to the 4th power off the top of my head. I mean, I'm good, I'm not that good. But we're going to use these numbers to now do our roots. So let's first start with numbers, and then we'll graduate up to variables. So finding roots, we're going to look for some basic roots. So 196, so this is a square root of 196. So we're looking for what times itself will give you 196, which in this case is 14. 14 times 14 is 196. Problem 2 works the same way. You just put the number 14. You don't have to write it as 14 squared. So in the case of example 2, since there's a 4 sitting outside, you're looking for what to the 4th power will give you 81. So you have to figure out what number could go in there and work. In this case, that's 3. 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So, numbers, not that difficult. So now we bring in variables. So last week, when we did the properties of exponents, we had a property for adding, we had a property for subtracting, we had a property for multiplying. We did not touch dividing exponents. That's because this is where the cup shows up. So when you have roots, that is a situation in which you would divide your exponents. So let's look at that with example 3. Square root of 16y to the 4th. So, for starters, the plus or minus doesn't really mean anything for the purposes of this problem. So we're just going to bring it over. Square root of 16 is simple enough. That's 4. Here's how we deal with the variables. Since it is a square root, there's an understood index of 2. So what you're going to do is take the exponent attached to the variable and divide it by the index, which is 2. Since it's a square root, it's an understood 2. The 2 will never be written. You have to put it yourself. Square roots have an understood 2. So when we divide, 4 divided by 2 is 2. So that becomes y squared. So your whole answer is 4y squared. Well, one, you're not doing that much, and two, the reason why I'm showing you like that is for problems like number 4. When I put a 5 out there. So I want you to be able to articulate the concept. So in the case of problem 4, we're doing the exact same thing. You have a fifth root. First off, you have the fifth root of 243. So you're looking for what number to the fifth power will give you 243. That's 3. After you take care of the number, then you take care of the variables. So for the variables, you take the exponent it already had and divide it by the index. So 20 divided by 5 is 4. Take the exponent, divide by the index, get b to the fifth. So your final answer is 3, a to the fourth, b to the fifth. That's that problem over. Questions 1, 2, 3, 4. As we start out with perfect squares. Just know they're not all about the perfect squares. Alright, seeing none, hearing none, let's move on. So, there will be times when either A, the number is in the perfect square, or B, the exponents will not divide evenly. To handle both of those cases, we introduce 2 other properties to help us simplify. Those would be the product property, which allows you to break up a radical using multiplication, and the quotient property, which allows you to break up a radical using division. So you are allowed to separate them out. So this does allow you to separate. So let's start with example 1. So we're going to start with the product property. So example 1 gives you the square root of 72. So 72 is not a perfect square. So what we have to do So we got to break up 72. So we have to find two numbers that multiply to 72, but one of them must be a perfect square because we want to break it down. So part of this is asking yourself, what are all the ways I can multiply to 72? So that's 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. So I'm looking for the biggest perfect square. That's 36. So we're going to use 36 and 2. Square root of 36 is 6. And the square root of 2 is 6. So that's your final simplified answer. So when you are simplifying, please do not give the answer of 8.48. Don't give a decimal. That's a surefire way to get it marked wrong. If you have to simplify something that's not a perfect square, you're simplifying something that's not a perfect square. Any questions? Example 1. Because you want the biggest perfect square. If you chose 4 and 18, that's fine, but that means you're going to break up. You have to break down to 18, so now you're creating more work. Okay. So just know if you pick a smaller perfect square, then you're creating more work for yourself. All right, example 2. So example 2, notice there's a 3 outside. So since there's a 3 outside, you have to use perfect cubes, not perfect squares. So you got to use perfect cubes, not perfect squares. So 54 is not a perfect cube. So we got to find two numbers that multiply to 54. One of them being a perfect cube. So let's think about, so 54 is 1 times 54, 2 times 27, 3 times 18, 6 times 9. So the perfect cubes are 1 and 27. 27 is bigger. So if you're wondering, how do I know that 27 is a perfect cube? There's my first 12 perfect cubes. 27 is a part of that list. So again, for some of you, you're going to have to review perfect squares and perfect cubes. Yes? Because if I'm going to use the 27, I have to use the 2 that was with it. I circled 1 and 27 because those are perfect cubes. But you have to select the biggest one. So now when we simplify it, the cube root of 27 is 3. The cube root of 2 doesn't simplify anymore. So that's finished. There's nothing else you can do with that problem. Questions on 1 and 2?
So, if
Mm-hmm.
Can't subdivide it or just bring it down together.
Just bring it down together.
Okay.
Good question. Any other questions? Problems 1 and 2. Alright, so now let's bring variables into the mix. So, example 3. We have 32x to the 9th power. So first we'll take care of the number before we take care of the variables. So we start with the number. So 32 breaks up into 16 times 2. Again, if you use 8 and 4, 4 is a perfect square, but that means you're going to have to do the problem twice. Square root of 16 is 4. The square root of 2 stays. Now you have x to the 9th. So for variables, remember, if you have a square root, there's an understood 2 as the index. So now you divide these out. 9 divided by 2. But 2 doesn't divide into 9 evenly. 2 divides into 9 4 times. You have a remainder of 1. So here's how this gets written. Since it divides evenly 4 times, one part of it is x to the 4th. You have 1 that's left over. That leftover goes back under the square root. So if you have leftovers, they're going back under the square root. Any questions on what was done? So now notice we have 2 parts. We can't have 2 parts. We need to combine them up to have one answer. So this is how that works. Whatever was on the outside stays outside. So 4 times x to the 4th is 4x to the 4th. Whatever was inside stays inside. 2 times x is 2x. So out stays out, in stays in. It's out, it stays out. It's in, it stays in. In this case, yes. I mean, putting them next to each other technically is multiplication. Now, if there was a 2 sitting in front of x to the 4th, you would multiply those together. But that's a good observation. Questions, example 3. All right, example 4. So example 4, we have 4th root, 625, a to the 24th, b to the 13th. So we have 3 separate parts. So, a fourth root of 625, luckily for us, that's a perfect fourth root. That's 5. So that number's perfect. A to the 24th divided by 4 is A to the 6. So that works out. B, however, doesn't work out all that nice. We have 13 over 4. 4 goes into 13 3 times. We have 1 remaining. So for the B's, you have B to the 3rd outside, and 1 B sitting inside. Because it was a fourth root. So that doesn't disappear. If it started as a fourth root, it's forever a fourth root. So now we take everything and put it together. So everything that's out stays out. Everything that's in stays in. It's out, it stays out. If it's in, it stays in. Why don't you put 2 in front of what? Because that's a square root. It's understood to be 2. Just like if you have x, you don't put 1 in front of it. It's understood to be 1. So you can put the 2 if you want to, just know that square root is understood to have 2. So it's not going to get written. So you have to know that as an understood value. Any other questions? Example 4. All right, go ahead and take about 60 seconds. Take a short break, very, very short break. If you need to stand up, stretch it out for a second. We'll start with example 5 in 1 minute. If it is given as a fraction, we can still separate it. If given as a fraction, we can still separate it. So, square root of 4 over 25 is the same thing as the square root of 4 over the square root of 25. The square root of 4 is 2, and the square root of 25 is 5. That's it, problem's over. So if you have the square root of a fraction, you separate it. And you leave it as a fraction. Do not give it as a decimal. Example 6, same way. It doesn't matter that there's a 3 sitting outside. It doesn't matter that it's a cube root. We still separate it. So we're dealing with variables, so we divide our exponents where we need to. So for y to the 9th, that's y 9 divided by 3, which is y to the 3rd. For 27, the cube root of 27 is 3. For z, that's z 6 divided by 3 is 2. Z to the 2nd power. And that's it, problem's over. Any questions, 5 or 6? If not, let's go to 7. So 7, we have square root 80 m to the 12th over 9. So if you see it sitting as a fraction, split it apart. So the easiest part in all this is the denominator. Square root of 9 is 3. So we know that the bottom is 3. It's the top that has to be dealt with. So for the number 80, 80 is not a perfect square. So we need two numbers that multiply to 80, one of them being the perfect square. So 4 times 20 would work. You'll have to do an extra step. But the two numbers that you could use and get it taken care of quicker, 16 and 5. 16 is the biggest one. Perfect square. 20 is not a perfect square. It's not just the biggest number, it's the biggest perfect square. So square root of 16 is 4. Square root of 5 is square root of 5. Now let's take care of the variable. Since there's a variable, you have to remember that a square root has the understood 2. So 12 divided by 2 is up to the 6. So remember, out and out, in stays in, out stays out, in stays in. Questions, 5, 6, or 7?
I have a question for number 7.
Go ahead.
Why did you fix 100 and squares x to 12?
Since you're dealing with a variable, and since it was a square root has an understood index of a 2. They will never write the 2 for a square root because it's understood. So you have to put it so that you have something to divide. But that's only for variables. You don't need that for the number. So, and this is very, very important. If you see a square root, that's the same thing as having the index of 2. The index of 2 is never going to be written. you have to know that that's an index of 2. That's something you have to commit to your memory banks. Good question. Make sure that's something that you keep an eye out for. Questions 5, 6, or 7? Okay, for some reason, it's not a hard problem, but you're gonna have to put in that work with multiplying and knowing what goes with what. Yep. All quizzes are an hour. You have to learn how to do things in a time setting. So since there's 15 questions, 60 divided by 15 is 4. So that's 4 minutes for every single question. And some questions won't take 4 minutes. Alright. So, before we start simplifying more than one radical, let's remind ourselves, what does it mean for something to be simplified? So for radicals, the index should be as small as possible. That's based on the nature of the problem. The radicand has to be simplified. That means nothing else, it can't be broken down any further. The two key things here, no fractions, so the answer can't be a fraction. Well, the answer inside of the radical can't be a fraction. And a radical cannot appear in the denominator. So if you have a fraction, you can't have a radical in the denominator. There is a way to get that out. We will do that on Monday. There is a way to get that out of there. That will take place on Monday. So, for now let's start doing multiplication. So multiplying means now we're doing more than one. So when we multiply radicals, you're multiplying what is inside of them. Now, if there was anything outside, we would multiply those too. We'll get to that in a second. So for example 1, square root 8 times square root 3 is square root 24. But you can't leave it like that. You gotta break it down. Square root 24 breaks up into 4 times 6. Square root of 4 is 2. Square root of 6 can't be broken down anymore. So that's your final answer. Again, when you're using your perfect numbers, you want the biggest one that you can possibly get. That way, it makes simplifying easier. If you use something smaller, you're going to be repeating the problem a couple times. All right, example 2, a little bit different, because now you have values outside the radical. So if you have things sitting on the outside, you multiply those first. So 12 and 5y have to get multiplied together. then the parts underneath the square root can be multiplied together. Out with out, in with in. Any questions so far? $60y stays the way it is for now. 20x to the fourth, you have to break down. So, square root of 20 can break up into 4 times 5. Square root of 4 is 2. Square root of 5 is the square root of 5. X to the fourth, remember, variables, you need the index. It's a square root. The index is 2. So 4 over 2 is x squared. Any questions before we move to the final answer? All right. You have 3 parts. You can't have 3 parts. You got to clean it up. So, out gets multiplied together. So 60y times 2 times x squared is 120 x squared y. Square root of 5 was the only radical left. That's your final answer. 120 x squared y times the square root of 5. So, yes, it's a mouthful. So since you have so many moving parts, you got to pay attention to what you're doing. Because 4 divided by 2 is 2, so it divided evenly, so it wouldn't go back underneath the square root. It would be outside the square root. So since it's outside, it goes with the 60y and goes with the 2. Any other questions with example 2 before we move to 3? All right, example 3. So, for example 3, it's very similar to example 2. So you have a 5 sitting outside. There's no number sitting outside there, so that's understood to be a 1. This 3 is the index for the radical. So you have 5 times 1. And then everything underneath the radical gets multiplied together. Again, the key thing for some of you will be doing it part by part. Some of you can do it in your head, great. Some of you are going to need to write it. 5 times 1, 5. If you multiply everything inside, that's 54a to the 6. Questions so far? All right, let's keep going. So 5, we don't have anything to do with it yet. So now let's deal with the 2 parts underneath the root. So cube root 54. So 54 is not perfect. So we need 2 numbers that multiply to 54, but one of them has to be a perfect cube. So of your perfect cubes, the only ones that will work are 27 and 2. Again, you're using perfect cubes, not the perfect square chart. Cube root of 27 is 3. The cube root of 2 can't simplify anymore. So the 5 is still floating out there, it's waiting. 8 is 6. So since you have a variable, you divide the exponents. So that gives you a squared. So that gives you a lot of stuff that needs to be cleaned up. 5 is outside of a square root. Well, a root. 3 is outside of a root. And a squared is outside of a root. So all 3 of them get multiplied together. Cube root of 2 is the only thing that stayed inside. So it stays that way. And that's your final answer for that one. Any questions? 1, 2, or 3? Well, turn off my recording.